Hello, this is Mertens from Graphene Info, and today we're going to talk about the CVD graphene industry and market. I'm going to give a short introduction to CVD graphene, the material itself, and then we're going to look at the current market status, and then we'll take a look at the industry. We're going to devote some time to discuss the situation in China, and finally we'll demonstrate some CVD graphene-based devices available on the market today. So graphene, as you probably know, is a two-dimensional sheet of carbon atoms arranged in a honeycomb lattice. Graphene has amazing properties. It is the world's most conductive material to both heat and electricity. It is extremely strong, it is flexible, and it has interesting optoelectronics properties. CVD is one possible method to create graphene. CVD stands for chemical vapor deposition, and as its name suggests, it uses a gas precursor to deposit high-quality solid materials. CVD is used in many industries and has many different types. CVD is one of the main methods, in fact, to create graphene. This is a bottom-up approach, which uses carbon atoms to synthesize a graphene sheet. Generally speaking, CVD tends to create high-quality materials, and it can be customized to create different types of materials. For example, you can control the number of layers in your graphene sheet. Usually, when using CVD, we deposit the graphene on a metal substrate, such as nickel or copper. It can also be done on silicon wafers. The graphene sheet can, however, be transferred to other substrates following the production step. As we said before, CVD graphene results usually in high-quality materials. It is also a relatively expensive process. This usually limits the applications to high-end ones. The main applications for CVD graphene that we identify today are in optoelectronic sensors and biomedical sensors. We also see adoption of CVD graphene in thermal films, used for heat generation mostly. CVD graphene can also be used to deposit conductive patterns, such as the ones used in solar panels or touch panels. High-quality graphene sheets can also be used to create membranes of all sorts. And finally, there are other applications for CVD graphene. For example, electronics interfaces, energy storage applications, which can use graphene films in batteries, this is one good example, LED devices, and more. Before we start to look at the current market and industry, I wanted to discuss two CVD graphene types, or production process types. The most straightforward design uses a sheet-by-sheet process. This means that the wafer is inserted into the CVD machine, the graphene is deposited on the wafer, and the wafer is then removed with the graphene coating on it. This type of process can be customized and can result in high-quality materials. It is quite common to use it. The main drawback is that it is slow, and so it tends to be expensive. The other way to use CVD is in a roll-to-roll process. In this kind of process, we deposit the graphene on a continuous roll, and the main advantage